Relative compression testing using the Snap-on DSO and a picoscope DSO. Here I'm going to start with the picoscope, where we use the amp probe to measure the current ramping of the compression stroke. We set this at the highest setting. Look at the arrow, that's the direction of the amp flow. We have to pay attention to that when we clamp it onto the battery cable. Now, use a USB cable and plug it into the laptop. Then, start the Pico software. Now let's configure it. Go over to the A channel and choose the resolution setting of 14 bits. That will clean it up just a little bit. Let's set our auto to 2 volts or plus or minus 2 volts. That'll give us 200 amps on the amp probe. And set our time value at 500 milliseconds per division. Now go down to the trigger and select a single trigger. Move the trigger over to the left and set it approximately 0.2 of a volt. Now, zero the picoscope and place the amp probe over the battery cable. Make sure to get the arrow in the correct direction and make sure the clamp completely clamps over that cable so it's closed completely. If it's not closed, it won't work properly. Now, disable the ignition by unplugging the distributor connector. And crank the engine over. Here we're looking for all even patterns. If they're even, we're good to go. If not, there's a problem. I'm now going to tighten some exhaust valves and retest to show you the results. I'll quickly pull the spark plug wires out and remove the valve cover. I'm going to set the cam in the correct position for cylinder number 4. Once I note that they're loose, I'm going to check the current setting. Both exhaust valves are set to 11 thousandths of an inch. That happens to be specification. Now, I'm going to arbitrarily tighten both valves a little bit. Here you'll see I cannot even get a 2 thousandths of an inch feeler gauge in there. And let's test again. We will now see that the scope pattern is no longer even. This is because 2 of the exhaust valves are too tight. Which exhaust valves are they? Well, you know because you saw me do it. However, if you don't know in the car, we're going to have to sync it up with the number 1 cylinder. We're going to use a secondary ignition probe connected to the second channel of the picoscope. Clamp it on cylinder number 1 spark plug wire and ground it. Now, we have to reconnect the ignition so we get a pattern. However, we have to disconnect the injectors so that the car won't start. Let's go ahead and set up the probe. Click the B channel and click the down arrow to change the probe. Scroll down and from the list, we want to choose Secondary Ignition Probe Inverted. Now, change the voltage scale to -5 and plus 50 kV. Now start the recording, and let's crank it again. Once we get both patterns, we can move the ignition pattern up so it syncs up with my amp pattern. If we know the firing order is 1, 3, 4, 2, we can now figure out which cylinder is lower than the other cylinders. Happens to be cylinder number 4, which matches up with what I did. I'm going to do a quick save so I can remember this pattern. Let's do another test. Let's arbitrarily really tighten these valves up a lot. Now let's crank the engine over again. Now we can really see how bad that number 4 cylinder is. It totally drops out on us. So let's set the valves back to 11 thousandths of an inch. I'm going to do the test one more time. Crank the engine over. Only this time I removed one of the spark plugs. Here we can see I removed spark plug number 2. Relative compression testing using your snap-on scope. Here I'm using a Modus, but most snap-on scopes are very similar. After turning it on, we navigate to the menu. We use the down arrow to choose the scope function. Then choose Lab Scope, and now choose 4-channel Lab Scope. If you have a scope with only 2 channels, that's what you would choose. Now we're going to use an amp probe, and we're going to connect it to channel number 1. Put the red lead into the channel number 1 and the black lead into the ground lead. 1 millivolt equals 1/1000th of a volt. 100 milliamps equals 1/10 of an amp. Since the starter motor draws between 100 amps and 200 amps, the voltage scale on the scope needs to be set to 2 volts. Now we will use the arrow button to the right and navigate over to the channel setting. Once you're at the channel setting, press the Y to open it. Go up to channel number 1 and set it to displayed and filtered. Turn both of these options on with a check mark, then use your left arrow and your N button to back out of this setting. Now navigate over to your test leads. Go down to the test lead mode and select test lead, even though we have an amp probe. Now over to the voltage setting. We want 2 volts. 2 volts will give us the ability to measure 200 amps for the starter draw. Now navigate over to the time setting. Set our time sweep to 200 milliseconds. That's the entire screen, not per division. Press the Y button. Finally, we're going to set the trigger to an automatic. Go up to channel 1 and make sure there's a check mark next to where it says auto. Finally, use the navigation to navigate over to the start, stop, or the pause play button. When you get there, press Y to pause it. Turn your amp probe onto the highest setting, then press the 0 button. Now check the arrow to make sure the amperage flow is in the right direction. The arrow needs to face your starter motor. Clamp it on your positive battery cable. Now disconnect your injector so the car won't start. Press the Y button to start the play option and crank the motor over. When it's done, press the Y button again to stop the play. Now navigate right to the zoom and choose the 8x zoom. Use your arrow buttons to navigate to view your screen. You can now see the humps from the amperage flow. Now let's sync cylinder number 1 secondary ignition to identify each compression stroke. Place a high intensity clamp over number 1 spark plug wire and ground it. Now I'm going to use an adapter to go from the BNC connector on my probe to my scope, which uses a banana jack. Disconnect the ground and put the adapter ground into the scope. Place the red lead into channel 2. Now I'm going to use a jumper wire to reconnect the ground for the amp clamp. Now press the Y button and let's configure the channel 2. Go over and make sure display is on inverted and peak detection. Go over to the test lead and choose ignition probe. And now select 15 kV for your voltage. Leave your sweep alone, but go to channel 2 trigger and make sure it's set to auto. Navigate to the pause button and press Y. When you're ready to crank the engine over, press the Y button again to record. Now crank the engine over. When finished, press the Y to stop the recording. Go back over to the zoom, choose the 8x mode, and navigate over to your pattern. You'll now be able to see where it syncs up with your ignition pattern, and you can identify which cylinder may have a problem. If you have a coilover plug system, you'll need to consult the wiring diagram to locate the ignition trigger wire point. Then, use a back probe pin to back probe that wire onto the coil. This is your primary ignition signal. Now connect your test lead for your scope and the ground lead for the scope. Now connect the BNC connector to your Pico scope channel or one of the channels on your snap-on scope.